Okay, well, welcome back for more. We are moving on to homework 8.5, the law of sines and the law of cosines. I hope you're having as much fun in this chapter as I am. Trig is extremely useful and wonderful, and nobody's chatting with me for a tutoring session, so you guys must be nailing this and doing a great job. So, well done. But remember, reach out. I'm happy to help and can teach pretty well over Zoom if you need assistance. But let's jump right in. Things are about to get interesting. We're going to be leaving SOHCAHTOA behind because what the law of sines and cosines allow us to do is to solve for triangles that are not right triangles, but any triangle, any three-sided triangle, that is. If you get that. And basically we have two definitions, the law of sines and the law of cosines. Sorry, I got to move my computer over here using that. That they are basically two formulas that you're going to want to memorize, and they're not too complicated, and you want to know when to use them. Those are the two big takeaways. What are these formulas, and when should I use them? So we'll start with the law of sines. So the law of sines, let's just picture a triangle here. Notice I'm purposely drawing a triangle that is not a right triangle. So we could not use the whole opposite over adjacent, opposite over hypotenuse thing because, hey, look, no hypotenuse. I don't have one here. So if I want to start solving for these angles, let's see. So those are my angles. Here's my side C. Here's my side B. Here's my side A. If I want to start solving for these, I can't use SOHCAHTOA. Oh no, what am I going to do? Law of sines. Have no fear. And so the law of sines is basically a ratio. We've done these before. It's a proportion. And it's not a complicated one, and so it's usually a favorite of students because it's pretty simple. And that is simply that the ratio of the sine of an angle over its corresponding side is the same as the ratio of another angle over its corresponding side, of all three. So the law of sines is usually written this way, which can be confusing unless we explain it. The sine of angle A over to side A is the same as the ratio of sine B over side B, and even though you don't extend a proportion three ways, it just shows that they're all equal to each other, that the sine of C is proportional to side C. And so that way, if I know, just like with a proportion, if I know any three values, I can find the fourth. And so if I redraw, I'm going to redraw a triangle here. And let's just imagine, here we got A, B, whoops, big B, and C, and just say randomly, I know this is 8, this is 7, and this is, we'll say 68 degrees. And you want to find side C. Okay, again, you can't use SOHCAHTOA here, but I can see that I know I can set up one of these proportions. And the simple way of setting up these proportions is this, actually, you know what? I'm going to change this. I've given you bad information. Let's go ahead and say we know this one is 8, because you're going to see why in a second. What I just set there would only work with law of cosines. Because the trick of whether you can use the law of sines, what you quickly look at is, do you have an angle and a side that you know? Do I know both an angle and its corresponding side? You have to have that in order to use the law of sines. Must have both angle and side that correspond in order to use this. And what that means is, I usually do something like this. I know angle C is 68 and I know side C is 8. If I did it like before, where I made the mistake, I had no situation like that. I had 8, but I didn't know B. I had 7, but I didn't know A. And I had angle C, but I didn't know. This law of sines would not work. And you're going to see that's why we need the law of cosines. So let's imagine a different scenario where I know these, and I want to find angle A. So I have one set that corresponds, and I want to use the other one that they've given me to find the other missing angle. So that allows me to set up a proportion. We're not going to solve it, but we're just talking about how things would be set up. So that means the sine of 68, that's the angle. The angle should always go next to the ratio. And then this is always the side, because that corresponds to C. And then I do not know sine of A, but I know sine of A is side. And so notice that is your typical proportion. I know 3 of the values. I do not know this value. And so when we do our questions, we'll talk about how to solve these, but you already know how to solve proportions. We're just going to cross multiply and divide, and we'll work through one of those. But the key is that you look for these across relationships, that you should know, you should have both the angle and the side that correspond. This is angle. Okay, and so I know I have this pairing, and then I pair up this other one with what's missing, and I can set up the proportion. Okay, and we'll work through one of those. Then the law of cosines is precisely for the situation that I described. Let's take another triangle, and I'll just recreate what I did there. Okay, where say I know this is 68, I know this is 7, and I know that we'll just call this 10 this time. And I have a situation where I have 10 here, but I don't have angle B. I have 7, but not angle A. I have angle C, but I do not have side C. And so I have, about to fly off the side here, I have no way of using the law of sines. I can't set up a proportion. If I set up a proportion, I'd be missing 2 rather than just one of the key pieces. So that's where the law of cosines comes in. Now the law of cosines looks terrifying, but we're going to try to explain how you use it. And that is, you can see there's a little Pythagorean theorem in it. It's c squared equals a squared plus b squared minus 2ac cosine, I'm sorry, ab, 2ab cosine c. Oh, baby. So what you have here, c squared equals a squared plus b squared minus 2ab cosine c. Praise the Lord. Going to kind of memorize that. You'll begin to see the logic of it the more you use of it. These two sides are the same sides. Notice they're sides because there's lowercase letters. This is a side. It's a lowercase letter. And it only uses one angle, and that is right here, cosine of that angle. Now, the way this is applied is if you set it up the way I recommend, you will only ever be solving for either side C or angle C. A and B you will always know. And I'm going to try to explain that here with 2 different examples. So if we go back to our triangle that we can't use the law of sines with, as soon as you see this, this is a side angle side scenario. Notice here are the 2 sides you do know are your A and your B. The angle you know that's in between them is then the only spot for an angle to go, which is here, which means the side I'm looking for is this side right here. And once you just, rather than worry about, well, what fits in and filling it in really slowly, if you kind of look at it and say, these are the 2 sides I know, here's the angle I know, so I'm going to leave this always as if I'm looking for a side, this is the side I don't know. So if we fill this in, we're going to get c squared equals 10 squared plus 7 squared minus 2, same A and B, so that's going to be 2 times 10 times 7, cosine of the angle I know, 68. And when we do the problem in a minute, we'll talk about how to solve that, but I'm just trying to get you used to setting it up. But this is a number. We just work carefully through the order of operations. We crunch this number, and when we square root it at the end, we will have C. And again, this is going to seem painful at first, but I promise you will get good at it if you work at it. Another situation where you're going to use, and I'll switch colors so it doesn't get too red here. Another situation where you're going to use the law of cosines. So you're going to use the law of sines as much as possible. It's much faster and easier for the most part. But there's 2 situations where you cannot use it. One is like here, and this is what I called your side angle side scenario, where I know the side and the angle in between. You're not going to be able to use the law of sines there. Or if you have this scenario where, say, you have 10, 7, and 8, 3 sides, and you have no angles. And you have no angles whatsoever. So that's the other reason you're going to use this law of cosines, because then what I can do is I can plug in all my sides and leave my angle as the variable, as the thing I'm going to find. And so the key here, as we plug this in, I show you how to set it up as one other example, is that depending on which angle they want you to find, It's how you're going to set it up. So if they say that I need to find angle C, then that means that I'm going to make sure that I call this, the one across from it, C here. So if I'm trying to find this, I'm going to start with 8 squared equals 10 squared plus 7 squared minus 2 times 10 times 7 cosine C. Now, if for some reason they say they want angle A, kind of ignore the letters, but think of it this way. If they want angle A, then I'm going to start with 7 squared equals 8 squared plus 10 squared minus 2 times 8 times 10 cosine, and you could put cosine A. You can put the different letters here. You just want to, just remember what this is the side you're looking for, or if you're looking for an angle, this is the angle you're looking for. And these two always correspond. So if I'm looking for this angle, depending on what the problem asks me for, then I would start with 10 squared equals 8 squared plus 7 squared minus 2 times 8 times 7. Okay? So just for the sake of it, let's say we're trying to find angle B, because I want to show you that you don't, just because this says C doesn't mean it has to be this one here. So say they actually want to find angle B. That means I'm going to start with the side across from that angle I want. Just like over here, I had this angle, so that means I was finding the side across from the angle I had. So I'm going to start with 10. 10 squared equals, and then I just use the other two angles. 8 squared, the order doesn't matter, 7 squared minus 2 times 8 times 7 cosine B. Okay? Because that's the angle I'm looking for. And the key is that this angle should always be across from this side. If you've set it up correctly, again, even going back to this one, this angle must be across from this side, and that is the correct situation. This, whatever you have here represented by the cosine, that has to be corresponding to the number here. And so I could solve this, and I could find what angle B is. So the key idea here is law of cosine works when you don't have a situation where you know the angle and the side across from each other. Notice I don't have that. I have 10, but I don't have the angle. Don't have the angle, don't have the angle. Or here, I don't have any combination. Law of sines, if you have that combination, use the law of sines. I think it's a lot faster. But if you have an SAS situation or an SSS situation, that's when you're going to use the law of cosines. So let's go ahead and wake up my computer. And let's look at the question. So question number 1, those are your two definitions. Question number 1, what can the law of sines and cosines do that regular triangles cannot? Well, that's what I was just saying. They can deal with and solve for angles and sides of what kind of triangles? Non-right triangles. So you can solve sides and angles for non-right triangles. That's the key. That's the main thing I'm trying to emphasize. If you have a right triangle, so katoa. But if you have a triangle that's not a right triangle, then you have the law of sines or the law of cosines to help you. Question number 2. What angles and sides must you have to use the law of sines? What grouping of sides and angles can you use the law of cosines with? So I've just said that, but I really want to drill that into you because one of your key difficulties of this lesson is saying, well, when do I use one? When do I use the other? Use the law of sines when you have both an angle and a side that correspond. Sines, use it when you have both an angle, both angle and side that correspond. And what that means is when we say correspond, that's basically meaning across from each other. Okay, so if I have a triangle here, I need to know both. If I know both a side and the opposite angle of any combination, I'm given those at the start of the problem, I can use the law of sines. The law of cosines, it's more easily just to remember what cosines can do. And if you don't have that, use the law of sines. But the law of cosines just has two specific cases. If you have a side angle side situation where they've given you side angle side, you're going to need to use the law of cosines because you don't have what you need for the law of sines. Or if you have the side, side, side. If you only know the sides and you need to find an angle, you're going to have to use the law of cosines. Okay, so we'll switch over. Now we just have 2 practice problems that we'll do. Let's see if I can leave this here. Can I fit everything in? We'll try it. Okay, so you had 3 questions. The third question, however, was just to practice on page 555. That's fun. Number 10 and 14. So number 10 is going to be using the law of sines, and number 14, the law of cosines. Because, let's see, number 10, it says we're trying to find, actually, let's see, I left off some information. Number 10, oh yeah, that's right. We know that this is 15. And we're trying to find RT, this distance here. Now, again, I don't like the way they say RT. I like learning that if this is angle S, this is side S. So I'm just going to call this side S, but it's the same as RT that they're asking us to find. Now, notice, why can we use the law of sines here? Because, look at that. I have a corresponding angle and its side. And I'm looking for the other corresponding angle and its side. So I always kind of draw it. That means I can use the law of sines, because remember, the law of sines is a proportion of the angle to the side. By the way, if for some reason they wanted RS or side T over here, I could quickly find angle T because I know these two. So I could find that if this was in fact the side they were looking for. But they're being simple today, and we just need this. So just set up your proportion. Start with the one you know, sine of 36 over 15, that's angle R and side R, equals sine of 70 over, now the missing side, S. So there is my proportion. All right, so I need to solve for side S. Now, if you remember, how do we solve proportions? We cross multiply. So we're going to get 15 times sine of 70 equals sine of 36 times S. All right, so this times this equals this times this. Now, how do I get S by itself? I undo the multiplication of timesing by sine 36. Remember, think of sine 36 and sine 70. That's a number. I can put that in my calculator and it's some usually ugly, irrational decimal. So just kind of keep those together, but this is a number. I know what this is. That's my variable. So I want to divide by sine 36 on both sides, because then that cancels out, and this is going to look ugly, but you'll get used to it. So now we just have that the side S must be equal to, notice what we just did, cross multiply and divide, cross multiply and divide. We multiplied, and now we're dividing by this. So that's the other quick way to do this. In a proportion, you cross multiply and divide. So S is equal to 15 times sine 70 over sine 36. Now, if you didn't have a calculator, that would be your final answer, but we do. And it says we're going to round our side length to the nearest tenth. Okay. So here we go. 15 times sine of 70. I'm going to go and calculate this first. Okay, then divided by the sine of 36, and we get 23.98. So we can round that up to the nearest whole. That's going to be 24.0. So S is equal to 24.0, which is correct. So that means S over here is 24. And there we go. We set up our proportion. We cross multiplied and divided, and then we've got our missing distance, 24. So again, law of sines, again, it's quite a bit of writing. Really encourage you to be neat, but it's the solving of it's pretty simple, as long as we set it all up right and we can put it in our calculator correctly. Okay, number 14, last practice problem. We need to find, it says to find side MN. We're looking for this side here. Again, I'm going to call it side L, because I think that's simpler. One less letter. But notice, I don't have a combination. I know 30, but I don't know angle N. I know 77, but I don't know angle side L. And I know 25, but I don't know angle M. So I cannot use the law of sines. I have, however, a side angle side relationship. That's how I know I can't use the law of sines. I'm going to have to use the law of cosines. Okay, so I know you've been practicing memorizing that. C squared equals a squared plus b squared minus 2ac 2ab cosine c. The way I remember it is I'm looking for either this, the middle angle, or the missing side across from it. So this is always the side. If I'm looking for this side, then this is the side that I start with. So I'm going to start with L squared equals, and then I just plug in the two sides that I know. 30 squared, I need to leave myself a lot of room for this. 30 squared plus 25 squared minus 2 times 30 times 25. Oh, yep, didn't leave myself enough room. Cosine 77. Sorry about that. It's a long sucker. Okay, but again, notice the angle I know is always across from the side that goes here. So that's the key, is that you set it up right. Now, what you need to do here is just work very carefully through your order of operations, where you need to do all your multiplication, all your squaring first before you add or subtract. You got to do all your adding and subtracting. That's probably where you could have this correct, and I see a lot of people in the calculation of it make mistakes. So let me show you how I recommend you work through these till you get really good at them, is figure out your squares. So we're going to try to create more room. L squared is equal to 30 squared is 900 plus 25 squared is 625. And then minus, and this is all multiplication. So I do all this together. Get out my calculator, and I would say, all right, 2 times 30 times 25 times cosine 77. Okay. And that to the 10th is fine. 337.4. 337.4. Okay. What I see a lot of people do is, again, they don't do their order of operations correctly here, and they'll square this and add this squared, and then they'll like subtract 2, and then they'll multiply, and you don't want to realize you have 3 operations here separated by a plus and a minus. And if you do those first, you're much more likely to come out successful. Because now I can do that calculation. I can do 900 plus 625 minus 337.4. And so I get 1187.6. So L squared equals 1187.6. Okay, and how do you undo the square? I just need to square root this number. So square root 1187.6, and I get 34, and I'm supposed to round it to the nearest whole degree, so I get not degree, tenth, so 34.5. So L, once I square root both sides, L is approximately, because we've rounded it, 34.5, which is in fact what we were looking for. So 34.5. Put that here. Oops. So L is 34.5, which again is proportional. I didn't get something crazy. If you finished, you're like, oh, it's 1,187. That's way bigger than the other two sides. Something's wrong there. Don't forget, this is the side squared. So you're always going to square root this at the end to get a smaller answer, 34.5. Okay, do not panic. I would say this is a difficult lesson just because of the level of arithmetic involved. You're going to want to be very neat in your work, and please reach out and get help if you need it. First several times you might struggle, but I promise if you work at it and you get the help and you're not afraid, you're humble and ask questions and put the time in, you can definitely do it. Law of cosines and sines.